Good morning, scientists. Today we're going to talk about space and space cats and what would happen to this cat if he was stuck in space for a very, very, very long time. Alright, so what's the point of today? By the end of today, you want to be able to understand and tabulate the effects of long-term space travel on our astronauts. And here we see Chris Hadfield, the coolest Canadian ever, aside from Neil Young, who's wringing out water from a wet cloth, and what you can see is that the water is actually not leaving the cloth, it's forming a nice bubble around there, and later on if we see it, it'll be spherical. Now, first we need to talk about what microgravity is. What is it that's allowing these astronauts to play football so well? Basically, we as humans, we've evolved in gravity of 1g, and that's Earth's gravity, that's the measure. Microgravity is the condition in space where basically the human body experiences very little gravity. This is what happens in space orbit. Now, we appear to be experiencing 0g, but that's because we're actually in free fall, the same as our surroundings. So, like our little spaceman in the cup, he falls at the exact same speed as.
And the crashing all day long.
They're crashing all day long, are they?
Yeah.
Okay, so they're falling at the same speed as the cup, and that means compared to their environments, they're weightless. Alright, space adaptation syndrome. What is it? This is the first problem you have. Basically, some astronauts suffer from SAD their first few days in space. So what are the symptoms? Essentially, spewing. You get persistent nausea and possible vomiting, and this is generally due to your inner ear, which is unable to stabilize, and that's what gives us our balance.
No, I do it.
Okay, press the button. Alright, so there's a treatment for it. Press it again. Alright. Whoop. Too far. Okay, so we have motion sickness medication. Basically, that's it. So he just takes a bunch of motion sickness medication, and you're good. And hopefully you're good anyway. Alright, so what happens to our musculoskeletal system?
No, I do it. No, press it.
Astronauts can suffer.
No, I do it.
Astronauts. We had a short problem. We're back. Basically, astronauts can suffer massive alterations. Cover your mouth. To the musculoskeletal system. This is rarely great. Like, this is usually a negative thing. Press the button. Alright, so this is largely due to the effects of not having to work against gravity. There's no resistance when you stand up. Like, you're not working against anything anymore. So you go to space looking like Homer in the mirror, and you can come back looking like this guy if you're there for long enough. Alright, so bones. Basically, our bones decrease in mass, and we're not entirely sure why. When they're not being used as much, the bones are unable to repair and remodel the way they normally do. And a break in space, which I'm not sure if it's ever happened, but it could be catastrophic because bones, they just don't repair the way they would. The body, it loses calcium because the bones aren't being used. They don't need the same strength they normally have, so the calcium is lost through the urine, and calcium is what gives our bones strength. Without calcium, the bones are all floppy. Big yawn. Tough day for science. Muscles. Muscles. Okay, so muscles make up approximately 40% of your body weight. Okay, and when load-bearing forces are reduced or eliminated, your muscles atrophy, and this means that they decrease in size and strength. Okay, so dietary. Dietary and exercise treatments are used to prevent this, and that's the same for the bone damage as well. So, but with the diet, they want a high calcium, high protein diet. Alright. Now, with the muscles, to be honest, it's not a huge problem in space because you don't have much to work against, so it's all fairly easy. The problems occur, and that's why they disappear in the first place. The problems occur when the astronauts return to Earth. Alright, now you have to do something. On page 262, there's a fantastic picture of an astronaut, and it's labelled with all sorts of health problems. I want you to tabulate the effects of weightlessness, I'm not going to give you any clues on how to do it, but I will tell you it's not acceptable if it's not good enough.
That's not space.
Can you say goodbye?
Goodbye.
Bye-bye.